Define the general solution to this third-order linear differential equation. Y triple prime plus y double prime plus y prime plus y equals 0. Step 1. We assume a solution of the form y equals e to the rx power. This is a standard approach for linear differential equations with constant coefficients. We then calculate the derivatives. Y prime equals r times e to the rx, y double prime equals r squared times e to the rx, and y triple prime equals r cubed times e to the rx. We substitute these derivatives into our original equation. This gives us r cubed e to the rx plus r squared e to the rx plus r times e to the rx plus e to the rx equals 0. We can factor out e to the rx since it's never 0. This gives us our characteristic equation. R cubed plus r squared plus r plus 1 equals 0. Step 2. We need to solve the characteristic equation. Let's try r equals -1 as a potential root. Substituting r equals -1, we get -1 cubed plus -1 squared plus -1 plus 1, which equals -1 plus 1 minus 1 plus 1, which equals 0. So r equals -1 is indeed a root. Since r equals -1 is a root, we can factor the characteristic polynomial as r plus 1 times a quadratic term. Using polynomial division, we get r plus 1 times r squared plus 1. Now we need to solve r squared plus 1 equals 0, which gives us r equals plus or minus I. So our three roots are r equals -1, r equals I, and r equals -I. Step 3. Now we write the general solution. For each root r, a basic solution is y equals e to the rx. With our three roots, we get three basic solutions. y1 equals e to the negative x, y2 equals e to the ix, and y3 equals e to the negative ix. We can convert the complex exponential solutions to real form using Euler's formula. E to the ix equals cosine x plus I sine x, and e to the negative ix equals cosine x minus I sine x. This gives us three real basic solutions: e to the negative x, cosine x, and sine x. The general solution is therefore y equals c1 times e to the negative x plus c2 times cosine x plus c3 times sine x, where c1, c2, and c3 are arbitrary constants. To summarize, we solved the differential equation y triple prime plus y double prime plus y prime plus y equals 0. We assumed a solution of the form e to the rx, found the characteristic equation, determined its roots, and converted complex solutions to real form. The general solution is y equals c1 times e to the negative x plus c2 times cosine x plus c3 times sine x, where the c values are arbitrary constants.